Back to the class of C programming. We are in chapter 7 about arrays. Array, it is a list of numbers, and we already reached to this point. This is how we declare an array. The name of the array, it is X. Number of elements in that array is 8, and the type, it is double type. Remember, in the C language, for our consideration, we only consider int, double, and char, 3 types. So this is an array of 8 elements. Certainly you can change this 8 to any number. For example, if you change 8 to 10, that means we are having an array with 10 elements. And also we mentioned briefly how we access each element. Each element, it is indexed with a subscript. And again, keep in mind, there's no actual subscription in the C language. The subscription, it is denoted by this pair of brackets. Okay, when you have an array of 8 elements, the index goes from 0 to 7 because we count from 0. And when you have, if this 8 is replaced with 10, the index would go from 0 to 9. And similarly, if we simply declare an array x of 3, so we are just going to have x0, x1, x2. That's 3 elements. Okay, so that is a double array of 8 elements. And for each element, you can assign with any value of this declared type, in this case, double type. And then roughly, we can say double type, it is about a decimal, mostly decimal numbers. Okay, the number with decimal points. So you can assign any value with to any element. That is an array. And also, the other thing was to mention, look at the representation on the textbook. This is an array. We say that x, okay, when we declare a variable, indeed, we are taking control of a piece of memory from the inside of computer, internal memory, a piece of internal memory, I'm sorry. And now when we declare an array of 8 elements, indeed, we are taking control of 8 pieces of internal memory. And the other thing was to mention here is you may want to keep in mind those memories are next to each other. When you declare an array of 8 elements, okay, those elements are stored in the memory next to each other. They stay together. Okay, this is a good thing to know, and later on we'll see we can do many different manipulations for array elements. But anyway, for now we are just doing the basics of arrays. And let's take a look at more examples about the array, and hopefully this can serve as for reviewing purpose. And this is a table as on the actual textbook. And the printf, usually it is a statement, it is a function used to output something on the screen. Remember the percentage mark for the double type, we use percentage %lf, and indeed, if you want to just print out, you use a single f that works too. And then we just want to print out one number, that is x0. So it prints out one number, x0. Okay, actually the array arrangement still have printed in the lower side. Okay, x0, which is 16.0. And x3, it is assigned as 25. And now, well, x3, remember, x3, it is the element that actually it is the 4th element. Originally, it is 26, now it is changed to 25 because of this assignment. And you can consider each array. Indeed, it is just true. An array element, it is just a single variable. An array element, it is single variable. And x, it is the name of the array. And also, if you are thinking what is the actual meaning of x without index, okay, without a subscript part, x, it is just pointer. It is the address, the beginning address of an array. That is the x. Okay. So for now, we are still working on those individual elements and consider each individual element just as a single variable. So you can carry out additions between elements, and you can use the increment operator on the array element, and the increment operator again. I hope you still remember. Anyone can tell what is the meaning of this assignment, this meaning of this statement, which means well, you are adding x2 to the variable of sum, and then the sum, it is still updated into the same variable. Okay, and plus equal the next line. Basically, it simply means x3, it is increased by 1.0. And then the last line, hopefully it's easier to understand. We are adding x1, x0 together, and the result, it is saved to x2. And x0, keep in mind, it is the first element. x2 is the third element. Okay. Basically, the array, when we declare an array, most importantly, we want to access each element of an array. Each element, it can be accessed using the subscript notation, not the actual subscript. Okay, the subscript notation, it is a pair of square brackets. X bracket 0 bracket, and that is the first element of the array, and so forth. x1 for the second element, and the last element for array of 8 elements, it is has the index of 7. Okay. And from the previous slide, we see we can declare an array of 8 elements, and also mention that you can replace keyword integer type or char type, or you can change the number to any number as you may need. Okay, and also there are other arrangements how you initialize an array. And basically, you can define integer type, and also let me try to see if I can make a quick fix here. It really, this is prime underscore prime underscore it underscore 100. It should be followed by a empty pair of brackets. Basically, it simply declares this is an identifier, right? Remember, an identifier, this is a user created name. Okay, an identifier, user defined identifier. And in C language, an identifier could start with a letter, an underscore mark, and followed by any mixture of letters and digits and underscore mark. So this is the name you create. And also to indicate you are creating a name for an array. And in this also you want to assign some values for the array. And you are going to use this empty pair of brackets. You are going to use this empty pair of brackets, okay. And then basically it says the first element, the element with index 0 is assigned to 2, assigned with 3, assigned with 5, 7, 11, and so forth. Okay, so forth. And also the next line, it simply says we are having vowels declared as an array, char type. And if you want to make the initial assignment, you can put equal sign there, and this is a long string. And each character, it is included in a pair of single prime notation. And now literally we call, okay, whatever the thing that you may have, whatever the characters or digits you may have, or ASCII codes, these are really ASCII codes, inside a pair of double quotation mark, it is considered a string. And then our next chapter, it is just dedicated for the study of string. For now, we just want to mention briefly, an array of characters is a string, okay. And you can, well, those two examples indicates you can declare an array, and at the same time, you can assign the value to each element. Declare each line, really, it is doing two things. This line here, and also I can see that's a line there. Okay, and also you better put a pair of, I think it doesn't need a semicolon there, okay. And you can declare an array at the same time, make the initial assignment for each element. And that is the so-called array initialization. Let's take a look at what we have on the next slide. This is a more general discussion. Syntax, okay. Array declaration, element type. Let's say element type, we only consider 3 types. Int type, double type, char type, okay. And then a name with size, a name, and followed by a pair of brackets, and then with size inside. It's say you are having like, well, I can type over here, maybe if I can move to the, well, I'm not going to change the screen for now. Just keep it like this way. Hopefully we will see more of the example in the following discussion, okay? And so like here, actually we do have an example right here. This still it is double type, A it is an array, size. Remember A size, it is define, the pound sign followed by the keyword define. It is the so-called constant macro. It is a constant macro in the C language. Okay, the C language will have to be compiled into machine language, or which is an object file. And the compiler recognize the keyword define, and then also it will do the following. If you get the define part correctly, whenever it sees a match A underscore size perfectly, again, C language is case sensitive. You can, well, in this case, we are all having uppercase letters. They are going to stay uppercase letters. If you change any of the letter to lowercase, that will be something different. If all the letters match, and then the entire thing will be replaced with this number 5. So indeed, this time it is declared as an array of size 5. And also worth to mention, element-wise, we are going to have A0 all the way to A4. There's no actual thing of A5, okay? Because in C language, in computer science, it's very common. Most of the time, we count from 0, because that is really the way how it works. And also, there's another way to declare an array, array initialization, okay? The next one, we are declaring vowels as an array of strings, and also at the same time, the first element of the array vowels, it is A. Second element is E. Third element is I, okay? And also this time, it's worth to mention briefly the difference between characters and strings. At least I want to remember clearly, a character should be included with a pair of single quotation mark. A string, it is included with a pair of double quotation mark. This is double quotation mark I'm talking about. Okay. This is for string. This is a long string. Indeed, it is. Okay. And now what we are having here is each individual number, it is a character. Together, they form a string. Okay, difference between a string and a character. And array subscription, and we don't write x underscore 3. And we write for the fourth element of the array, or indeed for the element with index 3, and it is written as x bracket, left bracket 3, then right bracket. And also for the index, you could put a variable there, which means whatever the I you may have, add by 1, and then together that the entire thing forms the index for the array element x. Okay. And let's take a look at what else we have. And still, we have more examples the way how to access array element. And printf. These are basically printf output statements, right? Percentage %d, it is for this 4, that's an integer. Percentage %d, that's for an integer. LF, it is for double type. But anyway, when you want to output a double type, use F is good enough. Okay. And then you access the array element. This really means X, the element with index 4, and in a common sense, this really would be the 5th element. And also you could use a variable as an index, I. And then indeed, well, these statements are kind of interesting. I guess the book did it purposely, put those kind of confusing expressions together. And well, this notation means, okay, the actual content of the ith element, it is indeed increased by 1, right? And this expression means the ith content of the array, it is increased by I. And the next one, be very careful about the index. When it is added to I first, inside the brackets. So we carry out to evaluate the expression inside the brackets first. And then the actual element we are referring to, it is the element with index I plus 1. And the next one, hopefully it's easier to understand, would be I plus I, or the index 2I. And somewhat I will say it is the equivalent to the next line there. And also one more line down, and basically you have the index multiplied by I, then minus 3. Minus 3, okay. And also, somewhat, this one a little more fancier. This one a little more fancier. And you are converting the x, it is the fourth, well, x, it is a double type. And somewhat we want to convert this into integer. So we take out the element with index 4, and then we convert them, force it to be an integer. And then it also can be used as the index for the array element again. And this one, I plus plus. Basically, I plus plus it is the increment operator. And this time, we know we could have prefix plus plus or postfix plus plus. They really have different meanings. Okay, if you want to see it clearly, basically the printf xi plus plus here is, it first will print out xi, and then I is increased by 1. The next line, it will really, because the minus the decrement operator works in a similar fashion like the increment. But now this time it is the prefix. It's a prefix. Okay, so I will be first decreased by 1, and then it prints out the element with the index I minus 1, postfix, prefix. Really, they have different meanings, and really you want to check closely if you do understand what I'm talking about. The increment operator could be placed before a variable or after variable. They are different. They are different. That's all I'm saying. And also, we basically, when we declare an array, each element can be accessed randomly as long as you have the index correctly. Okay. And also many times when we have an array, we really want to access the entire array or the elements in a sequential order. And if that is the case, usually it is accessed using a loop. Okay, it is implemented using a loop. So this time we are having a for loop, and remember the for loop, the syntax of for loop, it is followed by a pair of parentheses. And there are 3 parts. First part, it is the initialization of the condition, and then second part, it is the condition. If the condition is true, it, by the way, again, it's worth to mention when you have for, okay, it will check the condition first. I'm saying there's a potential issue when using for statement. It may not do anything in the body part of the for structure. But if the condition is true, certainly it will move into the body. It will move into the body. And then it will make the increment for the initialization. Okay, in this case, simply increase I by 1, and then it moves in to check the condition again. And if the condition holds, and then move into the body. So basically, this time we are really squaring each element of the array by itself. Squaring will multiply the element by itself, right? Okay, or the value of the array, it is assigned as the square of the corresponding index. It is very common. We use a for loop to access array elements in a sequential order. And how about let's take a break again? Thank you for watching.